back to another video for the mock test I took yesterday. Today I will do corrections and maybe make a video for the blank ones. Yeah, so this is the result. I got 17 correct, 5 wrong, and 3 blank. But like, to be honest, number 21, 22, I solved it in 1 minute. I didn't have much time, so I could say that I almost guessed those two problems, so that's why. But anyways, I got it incorrect. Number 10, 12, 14, I don't get it. I don't get why I got them wrong, but yes, anyhow. So my total score was 106.5. Not too satisfactory, but at least was Amy cut off. So now that I think about it, if I didn't make mistake in 10, 12, and 14, I would definitely get honor roll, for sure. But I made mistake, and that's my skill. So yes, so let's go over the incorrect problems. If you want to check how I solved the other problems, you can check my previous videos. But sorry, 10, 12, 14, 21, 22. We need to do 10, 12, 14, 21, and 22. I almost guessed these two problems, so I will make 23, 24, 25 for the next video because I didn't technically get it wrong. I didn't have time to solve it. But that's the same thing as getting wrong, but I mean, So let's do number 10. I remember this problem. So actually, while I was checking the answer for this problem, I didn't look at the solution, but I had to grade my stuffs, and I realized that I made a terrible mistake. So last time I remember making a solution like this, writing my solution. I showed two scenarios. Excuse me. I made them like this so that we have 5. However, I noticed that we actually don't need the middle one. And that's because if we choose 4 squares here, we're actually counting everything. We're not missing a single case. But this case, wait, oh no. But this case it doesn't work because it does miss few cases like this one. So this case doesn't work. But this case it works, so our answer should be 4. Number 12, I think the answer is 6 because I miscounted. I remember graphing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I remember going 1, 3, 5, 7, 9, so it's negative, and then 1, and then sorry, I remember graphing it like this, if my memory serves me right. I think it should look something like this. Wait, it is 10, right? From 10 is always positive. So that's why I chose 1, 2, 3, 4, 5. But I noticed that we have 11 disjoints, open intervals, and this thing, we should count this one too. So we actually have 6. I cannot believe that I made that mistake. Number 14. How many ordered pairs? So yeah, I don't actually remember my solution now. It's okay, we can solve it again. So we have m plus n. No, I will write everything in terms of m. So we have n squared minus 1 minus nm minus n squared equals 0. And plus or minus square root of b squared n squared minus 4ac plus 4 and 4 over 2a. This is n plus or minus. Yes, we can write it like this. Because n is supposed to be n is supposed to be an integer. But so, well, I think it is okay to take out n here because we have plus or minus here anyways. Oops. Like this. It could be minus plus or plus or minus, but doesn't really matter. We have the same m. So we have 4n squared minus 3. Now, this thing must be an integer. How should we solve it? So, first of all, 4n squared minus 3 should be the integer. Wait, is this the right way of solving it? I'm not sure. Or, because we might confuse ourselves, let's start from here. Yeah, I remember being stuck here, like last time I was solving this problem. Or it might be much more simpler than what we thought. Might be. So, when n equals 0, m equals 0, so m comma n, 0 comma 0 works. But actually, now that I think about it, the equation, it is cyclic. Not cyclic, symmetric. It is not like symmetric. Is it symmetric? No, it's not like symmetric, but like changing the value, like switching m and n, it doesn't really change the equation. That's what I wanted to say. So maybe if we find the value of m treating n as a constant, then we can find all the pairs of m comma n. And that is what I did right now. Maybe there is a different way. Minus m plus 2. So obviously 0 comma 0 works. Now because we don't have much values, should we like trial and error? Let's try 1 and wait. Okay. So when m equals 1, it does not work. Unless no, it doesn't work. When m equals 1, when m equals 1, n equals -1, so 1 comma -1 works. And similarly, -1 comma 1 should also work because I said it's, I found the word, reflective, not symmetric. Let me double check if my calculation is correct. 1. These two cancels out. We have 1 and 1. Yeah, so 1, 1 works. And that is the only solution. Let's try 2. 4 plus 2n plus n squared equals 4n squared. Does this work? Wait, did I make mistake or does it work? Why couldn't I cannot yes. I don't know why I couldn't think of this at first, but when n equals 3 it doesn't work. When m equals 3, 9 plus 3n, n squared equals 9n squared, 8n squared minus 3n minus 9 equals 0. So we have 3 no, but like it's really strange that if you actually put in 1 here, we get like extraneous solution. Maybe that's why. I mean, it's quite we need to use like limits to compute it if n equals 1, but anyhow. Wait, well, I'm quite curious, why does that happen? Oh, that happens because it's not quadratic anymore. Okay. 9 minus 4ac. 4ac? 4ac? 72? 4? 9? 2, 9. Oh, 7 doesn't work either. I don't think it will work. I don't think this thing will have like solution. So I think 0, is the only solution, but we need to check it. Yeah, we need to check it. So obviously, by looking at this 2, we have our answer is C, but like it's quite suspicious to have 5, 6, and 7. So we need to check it. By looking at this, let's write it like this: 4n squared minus 3 is equal to k squared, m plus k to m minus k equals 3. So you can either 1, 3, 3, 1, negative 1, negative 3, negative 3, negative 1. So we have n equals 1, n equals 1, n equals negative 1, n equals negative 1. Am I right? Yeah, I think so. Then I think we computed every cases, because this thing is a square number if and only if and this thing is a square number, and when n is an integer, if and only if n equals 1, when n equals 1. But obviously this case doesn't work. K must be a positive number. This case, negative 1. This case works. This case doesn't work. So the case only works if and only if n equals 1 and negative 1. And we counted that. Or when n equals 0, we just eliminate this one. So I think answer is 3. That's the only choice. Let's check our answers. We got C, C, oh, C, C, C. Oh, oops. Oh wait, what? Oh, checkerboard, here. Yeah, I didn't count some. Oh, no one graphed it for us. Wait, no one used graphing? Wait. Wait, graphing here. Yeah, I'm very curious. Wait. Oh. No, but like, uh, I'm not sure if, I'm not sure if this, wait, M times, oh yeah, it's actually, yeah, actually this solution is true. Oh, that's very clever. Anyone use the method that I used? Anyone? Maybe discriminant here? I don't think so. Oh, I should include my solution. I will read it thoroughly one more time, and then if no one has my solution, then I will go and edit. I deleted every annotation accidentally, so I got number 21 and 22 wrong. No, but like, to be honest, I couldn't like really solve it because I took like 30 seconds per problem for number 21 and 22. So I expected to, actually I took like I think around 40 seconds for 19, 20, 21, 22. So I expected to get a few wrong from these four problems, and I got these two wrong. 2023, I couldn't even read the questions properly. Three beans. Odd number. Okay, so I think it's the same as we have like split this with two bars. So obviously the total probability will be 2025. Choose. This is the total number of cases, obviously, right? But I'm not sure if that's really useful here. I remember choosing 1/2, and the reason behind that was we can either make 2023 equals odd plus odd plus odd, or odd plus even. But like other cases where we have even plus odd plus 1/3 means wait equals even plus even. The reason why I chose 1/2 is because I considered them as the same case. Wait, are the beans different beans? The answer should be 1/4, E. Yeah, answer is 1/. Oh wow, I didn't know that the beans are different beans. Wait, but why is the solution so? Oh wait, we have the same one. Yeah. Oh. I had the same solution as number 7, but okay. I think this one was like cheesy, I would say. What? Oh, okay. I think. Wait. I think. I didn't know that. I got it wrong because I misunderstood the problem. No. But I think solution number 7, which was like the same solution that I have, is the best one. It was like the shortest. Number 22. It'll be the last problem for this video. How many distinct value of x satisfy this? No, to be honest, this one I remember like and I got x equals 1 and 2 here. And then I realized that, like, okay, let's say that x equals like 1.2, 1.3. It will obviously not work because we will have fraction, like decimal here. But, and then like, if you have decimal here, and if you have like integers, it doesn't like work. So I guess that x should be an integer, so I got this. But I realized that this is wrong, not right. Okay, so maybe 1 over 3. Maybe 2. Oh, 2 over 3 works. Because I thought like this must be an integer, or else like integer plus integer minus something equals 0, and this one must be integer, so that's why I thought of only 1 and 2. But now I realize that we can do 2 over 3. Wait, then is our answer 3? Okay, is there any other integers that we can get from here? Negative numbers definitely doesn't work because we are going to square them. It's either 1 over 3 or 2 over 3. 1 over 3, it doesn't work. 2 over 3 does work. So I think our answer is D. C. What? Are you serious? D, 3. Did I say C? Wait. Oh, oops. Never mind. Okay. I will take a little more moment. I couldn't see the solution yet, so I will check what I missed. 1 and 2 works. How should we? Wait, what did I miss? I don't get it. I counted everything. X cannot be. Okay, let's use our old school method. X equals A plus alpha. We normally use A and alpha, right? No, we use N and alpha. Oh my goodness. I haven't solved these kind of problems in a while. I forgot. N and alpha. So you have n squared minus 3n minus 3 alpha plus 2 equals 0. And obviously alpha is in between 1 and like this. No wait, but notice that alpha must be 0 here. Or 1 over 3. So alpha equals 0, or alpha equals, I will say k over 3. There's no other choice, right? Let's start with our first case. N squared minus 3n plus 2 equals 0. N equals 1 and 2, and that's the solution that we have. Wait, why is it n? Oh, it's x. Okay, when alpha equals k over 3, then we have n squared minus 3n minus k plus 2 equals 0. Now, I think when k is 2, when k equals 2, n is 0 or 3. Oh, so this one works, and then, wait, did I say 0 or, I said 0 or 3, right? So 9, 11 over 3. It should also work, and let's quickly check it. We should have negative 9, 3, 9. Yeah, it works. Okay, we can continue. Next value. 1 obviously doesn't work. 4, it doesn't work, right? 4, no. What if k equals 6? I think it works. M minus 4, M plus 1. When k equals, so, oh yeah, and k also should not be the multiple of 3. And actually, if that's the case, then we should have counted everything. Oh, I guess I now understand why we have choice A. That's because we might not consider periods. Wait, what? We need to prove it more rigorously. 3. Oh, wait. 1, 2, 3, 4. 4 doesn't work, right? Yeah, 5 doesn't work. 6, 7. 7, 8. 8 doesn't work. 9 doesn't work. Should we just graph it? And oops. And 0 and 3 here. It used to be this one, but it moves like this, or it goes up. Wait, going up? It goes up? Wait, when it goes up, then we will not have. What am I doing? We can use quadratic formula. I cannot believe that. I thought of quadratic formula right now because I was trying to use discriminant. So n equals 3 plus or minus squares b squared minus 4ac. We have 4k plus 1 over 2. Now we did check that it works when k equals 2 and 11. Wait, 11? It works? Why does it? No, not 11, only 2. Now, when is this a square number? Oh, that's number theory problem. 4k plus 1 equals, which variables do we not use? I'll just say k prime squared. No, but that's not really helping. I now understand why we have the choice. An infinite number. But I think the solution, how do we prove that we don't have more from here? Okay, even if we no, isn't answer A? Why is it okay? We need to prove. Let's try and writing it. We might find something. 16, 20, 20, 24. What if x equals k cannot be equal to 6? 30, 36, 42, 48, 48. K cannot be 6. Right, I mean 12. 54, 60, 66, 72, 78, 84, 90, 96, 102, 108, 114, 120, 30. Okay, so I got it. So I mentioned that k cannot be a multiple of 3, right? K cannot be a multiple of 3. But if k is not a multiple of 3, then I don't think 4k plus 1 can be a square number. Like, just looking at this pattern. Because we counted these much cases and it's really rare to break this pattern, so the answer is 4. But it's not that rigorous. I wanted to see how other people solved it. Yeah, that's the same solution. But oh wait. Oh, A over 3, yes. Oh, we can change this. Ah, okay. Okay. Yeah, I don't think they tried. I mean, like, my solution was like really similar to the other one, the other ones that the other people noted. But yeah. Next video I will go over 23 to 25 because I couldn't touch those problems. Like